Hello everyone, I am Jeffrey Hunter. Welcome to the shop. Today we are going to be reviewing the Thermodynamics Cutmaster plasma cutter. Stand by. My God, it's beautiful. Oh, you're far too beautiful to be kept in a box. We have to bring you forward and show you to the world. Yeah, this is corny dialogue, but gotta keep people watching some way. Now, in the interest of full disclosure, I contacted Vector. I asked them if they would send me this unit. I told them I was a YouTuber. I do YouTube review videos. They said, heck yes, we love your stuff. We're gonna send it to you. Just give us a credit card number. So, baby, we're in. Please remit $1,269. They charged me? You said you loved me. It comes with the user manual on disc. And it comes with a couple of tips. And there is the front. It runs on 240 volts. There is no 120, it's strictly 240. It's got a nice long ground cable. I don't know how long exactly that is. And it has a really nice looking torch on it. And the torch is 20 feet long. Here is the back of the unit. We got our air input. And this is made in Mexico. Kind of surprising. I thought it would be made in China, but it is made in Mexico. The side of the unit has got a, well, it used to have a nice little side box on it until I ripped it off. This is where you keep your tips. User diagram there to see what tip goes where, how it goes together. And this is a 60 amp unit. It should cut an inch of steel. Now the torch is already assembled, but I'm going to go ahead and just show you how it assembles. That piece just snaps in place. These have the amperage stamped on them. I know you can't see that, but it has 60 amps. All the tips they give you are 60 amp tips. This little shield piece goes on next. That just pushes on. The tip goes into the cup. The cup here is threaded. And it feels like it's almost cross-threaded, but it's not. It goes on there fine. But it gets really tough to turn towards the end. Now you can see this torch has got a flat spot on it, so it only goes in one way. And the ground cable is already connected. Power cable is already connected. So that just pushes in and you turn it. And it has a little final click to tell you it's in all the way. Okay, the next thing we're going to do is to put this thing in the back of that thing. Okay, let's talk about the front control panel. The amperage is real easy, pretty self-explanatory. You turn it up the more amps you want. Now this selector knob here for the mode, when the selector is up into that one, you adjust your air. The two dotted lines there, that's normal operation. These four dotted lines are a constant arc. The arc stays lit all the time. You use that when you're doing expanded metal. And that position is what I thought was a lock position, but it's a position where if you've got a long cut, you press the trigger once and the trigger stays on. So you can use your hands to guide the torch instead of worrying about holding down the trigger. And when you get done with your cut, you just press the trigger again and the torch turns off. And these little LEDs on the bottom, that tells you the status of your power. AC power here, your over temperature, it turns on if you're in over temperature mode, is for airflow. This is your DC, which is your output here is DC. If there's something wrong with the DC voltage, that will light up. And the little exclamation point is an error. That means there's an error in the machine. And all of these LEDs correspond with a different error with the machine. So they have dual duty. They tell you that how much pressure you have for cutting. And also, when the error mode, you can look up to see what error is there with the number that the LED is lit up. Let me fire this thing up and show you quick what that looks like. Takes a couple seconds to start up, checks everything is okay, and you can see that it's running normally. We've got about 80 psi coming out of this torch. I'm going to go ahead and disconnect the air inlet. You can see right now we've got an error, and that error minimum means that there is no air pressure. And you can see it came back totally normal again once the error is fixed. Now this one here is your air adjust knob. You pull that out slightly and then you can adjust it up, down, however you want. And when you're done, you just push it back in and it's set. All right, I'm all geared up and I'm ready to make sparks. And here is the first initial cut with the plasma cutter. This is a chunk of 1/8 inch steel. It actually is my makeshift welding table. It's just a piece of 1/8 inch steel I drug out of the scrap bin and put it on top of my old workbench. I've been meaning to cut this part off. It's an excessive part to keep snagging my pants and everything on it. So after a year, I figure it's about high time it gets cut. And it's a whole lot easier with a plasma cutter. You can see I'm using a 2x4 here to balance the torch so I can get a nice straight cut on it. Next piece to cut is a piece of 1/2 inch thick steel. First thing you have to do is adjust the amperage from 30 to 50 amps. I have to take it a little bit slower with this thick of steel, but it's cutting it a lot better than I thought it was going to. It's kind of a beautiful sight, all those sparks going, and then she lets go and hits the ground. Just make sure you're aware of where your feet are so you don't get a hot foot. I want to see how this thing handles aluminum, so the next cut will be 1/8 inch aluminum stock. And I'm using 30 amps of current here also. The aluminum wasn't as easy to see as the cutting the steel with all the sparks of the steel, so at first I wasn't sure if I was cutting it or not, but I cut it just fine. Now with this cut, I'm just kind of screwing around a little bit. I've never actually cut copper with a plasma cutter before. This is some 1/16 inch copper. I just want to see how it will cut it. And that's a little bit screwy. I had to turn the amperage up a little bit. But it seemed to cut through it okay after I turned the amps up. You can really tell it takes more heat to cut through copper. Copper is a really good conductor of heat, so it takes a little extra amperage to get through it. And here's the slag from the 1/8 inch steel. That's the top part. You can see the bottom part is considerably worse, but that's where all the metal goes, is to the bottom when you're cutting. But it comes off pretty easily with a hammer. You just smack it, except for the part where I kind of got a little bit crazy with the cutting torch and stayed a little too long. That's going to take a grinder to get rid of. Here is the 1/2 inch steel, and you can see it did a pretty nice job of cutting. The waviness is my cutting. It's not the machine. And you can see it's a little bit bigger slag, bigger metal. You get bigger slag, but it comes right off with a chipping hammer. Next up is the aluminum, and you can see there's not a whole lot of slag on there at all. It actually cut it pretty nicely. And the slag that's on there comes off pretty easy, but it leaves stragglers, so you're probably going to have to use like a Scotch-Brite pad on an angle grinder to clean it up. And now for the fun stuff, the copper. It cut it good, but it looks really horrible, but it actually comes off with your fingers. You don't even have to beat on it. It just peels right off. It's kind of cool. You can clean that up with a little pickling solution. It'll be as good as new. Okay, final thoughts. One phrase comes to mind. Kick ass. Thermodynamics makes a hell of a nice plasma cutter. That's as good a plasma cutter as I've ever used. Now, this may come as somewhat of a shock, so brace yourself. I am not a plasma cutter expert, as you can tell from my cuts.
You suck!
I need a little more practice, shall we say, but I have used plasma cutters in the past. I've used cheap ones, I've used expensive ones. This is one of the best ones I've ever used. It cut through that 1/2 inch steel just as easily as it cut through 1/8 inch steel. I honestly didn't notice any difference. I just cranked the amps up, hit the button, and it cut it perfectly. There's no doubt in my mind this thing would cut through a 1 inch thick piece of steel. Probably would not look good when you're done. It's rated to 1 inch sever quality, which means it'll cut it, but it's not going to look good. But as you can see with that 1/2 inch, it cut it perfect. But as far as ease of use, couldn't be simpler. A couple of knobs to turn, you can figure it out real fast, you're done. Quality of the machine, the hoses, the cables, the ground clamp, everything is really nice. It really is a well-built machine, but you will pay for it. This thing, I got it from Cyberweld. I got it, I believe it's a closeout model or a clearance model. It was $1,200 plus tax. Shipping was free, but quality stuff doesn't come cheap. And for what I'm going to be using it for, absolutely perfect. I cannot believe I was on the verge of buying the plasma cutter from Harbor Freight. Yes, it would have been half the price. I just don't think it would have held up as well as this unit did. There's no way. And that is the Thermodynamics plasma cutter. Now get out there and just build something. Hello everyone, I am Jeffrey Hunter. Welcome to the shop. Today we are going to be reviewing the Thermodynamics Cutmaster